Angler change detection. Change detection is the process by which Angler automatically updates the user interface. Whenever the application's data changes, it keeps the component data and the HTML view synchronized. Developers do not need to manually update the DOM. What is the need of change detection? Without the change detection, users see outdated information. Developer manually update the user interface, more coding effort, and then high chance of errors. By using the change detection, automatic user interface update, and then the faster development, and then we create the better application performance. And then keep the user interface synchronized with the application data. Eliminate the manual DOM manipulation. It improves the application responsiveness. It simplifies the development. It enhances the user interface. For example, when a user changes the quantity of the product, the total price updated automatically. This is the working process for the change detection. In step 1, user perform an action. User interact with the application by performing an event such as clicking a button, entering text in the text box, select an option from a drop-down, submitting a form, receiving data from an API, a timer executing, an observable or promise returning new data. For example, a customer clicked the add to cart button on an online shopping website. So before click, product quantity is equal to 1, total price equal to 50,000. Here the user action is the customer clicked the add button. In step 2, component data changes. The event triggers a method in the Angular component. This method updates the variables or properties. For example, before quantity is equal to 1, after clicking add, now quantity is equal to 2. It changes automatically. Similarly, the total price is recalculated. Before total price equal to 50,000, but after clicking add, total price equal to 1 lakh. At this stage, only the component data has changed. The web page has not yet been updated. In step 3, Angler detect the change. Angler continuously listen for changes caused by user event, HTTP or API responses, timer, promises, observables. For example, after customer click the add button, Angler detects that the quantity variable has changed from 1 to 2. Angler uses Zone.js to monitor these asynchronous events. Whenever event occurs, Zone.js notifies Angler that some data may have changed. Angler then starts the change detection process. In this step 4, Angler compares old and new values. Angler checks the current value of the component properties against their previous value. For example, initially the old value is equal to 1 and the new value is equal to 2. And similarly, total price initially 50,000 and then the new value is 1 lakh. Angler identify which value have changed. If a value had changed, Angler mark the corresponding part of the user interface for updating. If there is no change, Angler leaves that part of the UA unchanged. In step 5, the UA is automatically updated. Angler update only the HTML element that display the change value. The browser screen immediately reflects the new data without refreshing the page. Here, before update, quantity, the total price are 1 and 50,000. After update, quantity and total price are changed automatically. The user sees the updated quantity and the total price instantly. So this is the overall working flow for the change detection. First, user click or otherwise it types the input or API response. Then component data changes and then zone.ds detect the event. Then Angler start the change detection. Then compare the old value with the new value. Then we have to identify the change value and then update only the record HTML element. So finally, user sees the updated user interface. Here, the real-time examples are student management system. Suppose a faculty member updates a student attendance. So before update student name attendance, faculty changes attendance 79% and click save. So the working process, the faculty clicks save. The attendance value changes from 78 to 79. Angler detect the updated attendance. Angler compare the old value with the new value. Finally, in the student portal, immediately display the 79% without reloading the page. Here, the advantages are automatic user interface synchronization. Angler automatically update the user interface whenever the application data changes. Developer do not need to refresh the page manually. For example, whenever a customer increased the product quantity, the total price updated instantly. The second one, it reduces the manual coding. Angular automatically update the DOM web page, reducing the need for manual JavaScript code. This saves the development time and minimizes the coding error. The third one, better user experience. Users see updated information immediately without refreshing the page. This makes the application faster, smoother, and more interactive. For example, a live chat application display the new messages instantly. The fourth one is faster development. Since Angular handles the user interface update automatically, developer can focus on business logic instead of updating the HTML manually. This speed up applications development. The fifth one is it supports the real-time applications. Change detections enable the applications to display the real-time data as soon as it changes. It is useful for the applications such as online banking, e-commerce website, live chat application, stock market dashboard, and then the student management system. The final one is it improves the maintainability. The code becomes cleaner, easier to understand, and easier to maintain. Future updates and bug fixes can be implemented with less effort. Then disadvantages of Angular 8 change detection. The first one is frequent changing may reduce performance. Angular check for changes after every user event, API response or timer. In large applications, these repeated changes can slow down the performance. For example, a dashboard with many live updates may become slower if all components are checked frequently. Then the second one, large component tree take more time. By default, Angular check the entire component tree. If an application has many nested components, change reductions takes longer to complete. For example, an e-commerce website with hundreds of product components require more time to check all the components. The third one is the tracker optimization for enterprise applications. Large enterprise applications with thousands of components need performance optimization. Developers often use techniques like on-push detection, lazy loading, and efficient data handling to improve the speed. For example, banking or hospital management system use the optimization technique to handle the large amount of data efficiently. The final one is insufficient if not using on push where appropriate. The default strategy checks every component even when many components have not changed. This can result unnecessary processing and reduce the performance. Using the on push strategy allows the angler to check only the component whose input data has changed. For example, in a news application, If only one article is updated, on push represents only that article instead of checking the entire page. And then the applications of Angular 8 change reductions. So it is used in various applications. E-commerce website automatically update the product quantity, shopping cart, and total price when user add or remove items. So example, Amazon and Flipkart. And then online banking system display the updated account balance and transaction history immediately after a transaction. For example, internet banking applications. Third one, hospital management system. Update the patient's record, appointment status, and doctor availability in real time. So example, hospital management portals. Fourth one, student management system. Instantly update the attendance, internal mark, assignment status, and exam result. For example, college ERP portals. Fifth one, chat applications. Display the new messages instantly without refreshing the page. For example, WhatsApp web or stack. The sixth one is food delivery applications. Update the order status such as order confirm, preparing out for delivery, and delivered in real time. For example, Swiggy, Zomato. And then the weather applications automatically refreshes the weather applications such as temperature, humidity, and forecast when new data is received. Example weather apps. The final one is stock market dashboard. Continuously update the stock price, market indices, and chart as new markets data arise. For example, NSE or BSE trading platform. And then the change detection triggers. Angular runs the change detections when button click, keyboard input, mouse event, HTTP or API response, timer, observable data, and then promise completions. For example, login box, search box, live notification, weather updates. So here the change reduction strategies are two types, default strategy as well as on-push strategy. In default strategy, it's check all the component easy to use, suitable for small and medium applications. In on-push strategy, check only the when input data changes, faster performance, best for the large applications. So the main difference between the default and on-push are it check all the components. Here it check only the regular component. It is slower and on-push is faster. It is easily and on-push is optimized. So these are the features of default change reduction strategy. Checks to every component. It run after every event. Easy to implement. Suitable for small and medium sized applications. So the advantages are automatic update and easy maintenance. So simple example for default and versus on-push change reductions. So the scenario is student portal. The portal has two components, student marks as well as student profile. The teacher updates the student mark from 80 to 90 or the default stage reduction strategy. Angular check both the component even though only the marks are changed. So before update, student marks equal to 80, student profile is equal to no change. After update, student marks checked and updated. Student profile checked even though nothing's changed. Angular check all the component which may take more times in large applications. And then the on push strategy. Angular check only the student mark component because that only is data changed. So before update, student marks equal to 80, student profile is equal to no change. So after update, it only check the student mark. So Angular update only the changed component. It improve the performance. So this is the difference between the default and on-push strategy. It takes more processing, it takes less processing. It's suitable for smaller applications, it's suitable for large applications. So the futures of on-put strategy reductions are it checks only when at input reference changes. It gives a better performance. It's suitable for larger applications. So the advantages are faster rendering, it reduces unnecessary checks, and it improves the scalability. So the Angular change reduction steps are so for totally 6 steps are there. First one is user interaction. So the process begins when the user interacts with the applications. For example, include clicking a button, typing in a text box, selecting an option, or submitting a form. For example, a user click add to cart button. Second one, event generator. The user action generated an event such as click, keyboard input, mouse movement, or API response. This event tells the angler that an action has occurred. For example, clicking the add button generates a click event. The third one is Angler Zone Detect event. Angler uses the don't.js to monitor all the asynchronous events such as user actions, API calls, timers, and promises. Whenever event occurs, don't.js notify the angler to check for all the data changes. Example, don't.js detect the button click and informs Angler. The fourth one is change reduction start. Angler start the change reduction process to check whether any component data has changed after the event. For example, the product quantity changes from 1 to 2. The fifth one is component tree checked. Angler check the component tree to identify which component have updated data. So in the default strategy, all components are checked. In on-put strategy, only the component which changed input are checked. The sixth one is DOM updated. So Angular update only the affected HTML element in the DOM. The user immediately sees the updated information without pressing the page. For example, the shopping cart display. Here the quantity is to total prices 1 lakh. So that's all about Angular change reduction.